Good morning, students. Last class we defined with what is base theorem. Using the formula, we worked out few problems in the previous class on base theorem. We'll continue with few more problems on base theorem. Last class we have done with 4 problems. The next fifth one we will continue with this. The next problem, the data what is given is a doctor is to visit a patient from the past experience. It is known that the probabilities that he will come by, the doctor who is visiting the patient, he can come by the following. What are those? He will come by train, bus, scooter, or by other means of transport. So there are 4 different means of transport what a doctor takes to visit the patient. So when a doctor visits the patient, he is taking 4 different means of transport in each different time. And the probabilities of that are given as other means of transport are 3 by 10, 1 by 5, 1 by 10 and 2 by 5. They've given the probabilities of that. The probabilities that he will be late. So when he travels to meet the patient, the doctor visits the patient, he's going to use either train, bus, scooter or other means of. But there are chances of him getting late, that is event A, are 1 by 4, 1 by 3 and 1 by 12. 3 conditions are given. If he comes by train, bus, scooter. So he can have chances when he takes a train. He may be late by 1 by 4 probability. By bus when he comes, he may be late by 1 by 2. By scooter, it is 1 by 12. But if he comes by other means of transport, then he will not be late. If he takes any other means of transport, then he will not be late. It's not going to become late if he is using any other means of transport. That is the 4th condition. When he arrives, he is late. So that is an event occurred. That he is coming late is the event occurred. What is the probability that he comes by train? So the first means of transport, that is train is the first means of transport what is taken. What are the chances of coming late when he takes train? So train is an event where he is coming late. Using that he is coming late, what is the probability? That we will try to find from base. So once the question is read out, now we will analyze this. What does it say? A patient is going to be visited by a doctor by 4 means of transport, either by train, bus, scooter or other means of transport. And the probabilities of these are given. The next chances, they are saying that there is one more event occurred. That event is coming late. Then when he takes train, what are the chances of coming late? When he takes bus and when he takes scooter. And they've also mentioned when he takes the other means of transport, he will not be late. He will not be late when he takes the other means of transport. But however, finally when he comes, he is arriving late. So they've asked him to find the probability that it comes when using train. So train is one of the events. In that event, what are the chances of coming late? You have to find using this. So let me write down the data. In the previous class, I told you number of events what is given in the list. So here a doctor is visiting the patient by what are the chances he takes, by what are the means of transport he takes is train, bus, scooter and other means of transport. So there are 4 means what I am taking. E1, E2, E3, E4. E1 is the event by train. The next one is by bus. The third one is by scooter. What is the 4th one? Or by other means of transport. Other means of transport. So these are the 4 events what is happening. Maybe train, bus, scooter and other means of transport. These are the ones what the doctor uses to visit the patient. So I define them as E1, E2, E3 and E4. Then what is here the A event which is occurring, that is coming late. Coming late, because the probabilities of coming late are being given. The probability will be late are 1 by 4, 1 by 3, 1 by 12. So that event A is nothing but coming late. Now using this, let me write down the condition. First one, probability of E1, probability of E2, probability of E3, probability of E4. What is the number of favorable outcomes divided by total number of. Now let me see what do I mean by this. How many events are occurring? 4 events. There are 4 ways by which the doctor is traveling. So the total number is 4. The chances of event 1 is by train is coming is 1 by. The chances, sorry, here the probabilities are mentioned. I cannot take this. Probabilities are mentioned, I consider this. The total event is correct 1 by. But here, when they have given the chances, that the probabilities, they already defined the probabilities that will come by train, bus, scooter, and other means of transport. The 4 data are already given, so that I substitute. What is given? The chances, that is the probabilities, known that the probabilities, they have already given in the data. Whereas in the previous problems, we did not have, but in this problem, they have given. The probabilities that will come by these means are respectively 3 by 10, 1 by 5, 1 by 10, and 2 by 5. So what is it? It is known that the probability that will come by train, the first bit E1, what is it? 3 by 10. Then by bus, 1 by 5. Then by scooter, 1 by 10. Then the next one, other means of transport, that is the fourth one, 2 by 5. So probabilities are already defined. I'll write down that in the data. Probability of E1, what is the event E1? By train is 3 by 10. By buses, 1 by 5. By scooters, 1 by 10. And last one, that is other means of transport, is 2 by 5. Then the event coming late is A event. So let me see the chances of this. Probability of coming late by train is given. Probability of coming late by bus is given. Probability of coming late by scooter. Probability of coming late by other means of transport. These are the 4. So here the next statement says the probabilities that he will come late are 1 by 4. 1 by 3, 1 by 12. If he comes by first by train first one if I take 1 by 2. Coming late by train is 1 by 2. Coming late by bus, the second one is 1 by 2. Coming late by scooter, the third one is nothing but 1 by 2. Coming late by other means of transport, he will never be late everywhere. But if he comes by other means of transport, then he will not be late. Not be late means I take it as C. It is not late at all, they are saying, so it is nothing but C. This is what is the data what is asked to find. What is the probability that he comes by train? Train is the first event what is happening. What is the probability that is coming by train and is coming late? That we have to find using this. Probability that is coming by train. Train is event 1. So probability of E1 by taking the train by coming late. This we have to find. Now this is the data what we have. Reading the question we have analyzed this. Now we will work on this using the formula of base theorem. So I have written the data below. About this we will work on. What we have to find? Probability of taking the train and coming late. Probability of taking the train and coming late. So it is probability of E1 into probability of coming late by train. Whole divided by the summation. How many events are occurring? 4 events. So it should be sum of 4 terms. Probability of E1 into probability of coming late by E1 plus probability of E2 into probability of E2 plus probability of E3 into probability of coming late by E3 plus probability of E4 and probability of coming late by E3. This is the formula of Bayes theorem when I have to find probability of coming by train and getting late. Probability of coming by train and getting late, then we substitute the values. We have already written from the question what are the values we have got for individual one. Let me substitute. Probability of E1 I want. Is it 3 by 10 into probability of coming late by train is 1 by divided by, again it is 3 by 10 into 1 by 4. The same thing. Probability of E1 and probability of A on condition plus probability of E2. What is E2? 1 by 5 into probability of coming late by bus, the second unit, that is 1 by 2 plus probability of E3, 1 by 10 into probability of coming late by E3, that is 1 by 10 plus probability of E4, 2 by 5 into probability of coming late by E4, that is 0. Because they told by other means of transport you will never get late. So we took it as 0. Now, let me see what is the common one. So if I simplify this, I wrote a common multiple directly, shall I simplify? 3 by 40 divided by next one, 3 by 40 plus 1 by 15, 3 5s up, plus 1 by 120 plus 0. If I try to rearrange this, 3 by 40 divided by, in the denominator I have sum of 4 terms. So let me try to simplify this. I'll have the data what is given for the simplification. If I have a common multiple, let me take down 3 by 40 divided by. Shall I say 1 by 5 is the common multiple I will take out from all these fractions? 3 by 8, 5 8s are 40, plus 1 by 3, 3 5s are 15, plus 1 by, I'll take out 5. So it is 2 into 12, it is 24. 5 2s are, so I can take it as 24. Now, shall I simplify this? I'll just rearrange here only. Okay, continue with this. So 5 and 40 I can cancel. In the denominator, let me take the LCM. Three by 40 into 1 by 1. What is the LCM shall I take? What are the multiples? I have in the denominator 3, 8 and 24. Then what shall I consider? 3 1s are 8s are 3 8s are 24. So it is 8 what I can consider. So 24 is the LCM. 8 3s are 3 3s are 9 plus 3 8s are plus 1. Now 3 by 40 divided by 1 by 5 into 5 add up this 18 by 24. 18 by 24. So 3 by 40 into, if I bring it to the numerator, 5 into 24 divided by 18. So I simplify, 5 1s are 5 8s are, and 3 1s are 3 6s are. Again 8 3s are 1 by 2. 1 by 2 is the value what I am getting. Probability of taking a train and coming late is nothing but half. Probability of taking a train and coming late is half. So simplify that fraction, you have to get back the answer as half. Let us continue with the next one. The next question. Two groups are competing for the position on the board of directors of corporation. The probabilities that the first and the second group will win are 0.6 and 0.4 respectively. The probabilities are defined respectively. Further, if the first group wins, the probability of introducing the new product is 0.7. and the probability is 0.3 in the second group wins. Find the probability that that new product was introduced by the second group. So they are saying that there is a position for which the two groups are competing. The probabilities of the first and the second group. Therefore, the groups are competing by first and the second group. So E1 and E2 will compete. First group and second group again considered. For a position, there are two groups which are competing, and these are the two events what are occurring, E1 and E2. So they have already given the probabilities of like the previous problem. What is that? The probabilities that the first and the second group will win are 0.6 and 0.4. So there are two groups competing, and the chances of winning, the two groups will win. The chances of that probability is defined as 0.6 and 0.4. They have told further, if the first group wins, the first group chances of winning, the probability introducing a new product. So A, the event what I consider is the new product is nothing but the A event what we can consider. So probability of event A, new product, if group 1 wins, if the first group wins, the probability of introducing a new product is A, by first group is given by 0.7 and the probability is 0.3 when if the second group wins. So probability of introducing a new product by the second group is 0.3. Find the probability that the new product is introduced by the second group. Probability by second group introducing the new product. This is what I have to find. So in the data, it says there are two groups and the chances of winning the two groups is given. Probability of group 1 winning and probability of group 2 winning. And once they win, they introduce a new product, and that product chances of introducing a new product by group 1 is 0.7 and introducing a new product by group 2 is 0.3. I find probability of asked is introducing a new product by second group. But second group introducing new product is probability of E2 into probability of new product of the second group. Whole divided by, there are two events occurring, so I take the chances of two events plus probability of E2 into probability of E1. The denominator it is the summation, but there are only two events occur. I consider. Substitute the data. E2 is given as 0.4 into probability of new product by E2 is 0.2. Whole divided by probability of E1 is 0.6 into probability of a new product by E1 is 0.7 plus the next one, probability of E2. E2 is nothing but given as 0.4 into probability of new product by E2. 2 is 0.2. Let me simplify this. 0.4 into 0.3, 0.12. 4 3s are 12. After 2, the decimal place and 3. Then 6 7s are. What do I get back? Plus, so 42, 6 7s are 42, plus again 0.12. So if I simplify this further, I continue here. (0.12) divided by, if I add up this 0.54. So 12 by 52. If I consider which table, I consider two tables, 6, 27. Then again 3 tables, 3 2s are 3 9s are 2 by 9. 2 by 9. So first, the decimal places I multiplied 0.12, 6 7s are 42. After 2, the decimal place, so 0.42 plus 4 3s are 12, 0.12. So 0.12 I kept as it is. When I added this 0.52, after 2 decimal places I will take it out. 12 by 54. 2 multiples when I consider 6 by 27. I get 3 multiples 2 by 9. Let us consider next one. Next problem. In answering a question on a multiple choice test, a student either knows the answers or guesses. Let 3 by 4 be the probability that he knows the answer and 1 by 4 be the probability that he guesses. Assuming that a student who guesses at the answer will be correct with probability 1 by 4, what is the probability that the student knows the answer given that he is answered it correctly? So this question says that there is a question on a multiple choice where a student is answering. And the student either answers it or he guesses. Either he knows the answer correctly, he answers it, or he guesses. So they're given the probability is 3 by 4 when he knows the answer. Out of the 4 multiple choice, which is the answer, what he knows, the probability is 3 by 4. And the probability of guessing is 1 by 4. Assuming that the student who guesses at the answer will be correct. The correct answer given is event A, what is occurred. With the probability of 1 by 4, chances of guessing and getting the correct answer is 1 by 4. You have to find what is the probability the student knows the answer. That is knowing the answer and given that the answer is correct. So once the question is given, a student on a multiple choice either knows the answers or guesses the answer. So there are 2 events what is happening. Event 1 knows the answer. Event 2 guesses the answer. So 2 chances are there. Either he knows the answer or he guesses the answer. 2 events when a question on a multiple choice. And A is an event where it is given the correct answer. So chances of this will 1. Now let me see what are the probabilities given. Probability of E1 and E2 is given. When a student looks at the question, the chances that he knows the answer is given and the chances he guesses. What is it given? Let 3 by 4 be the probability that he knows the answer. So knows the answer is E1, event occur. So that is probability 3 by 4. 1 by 4 be the probability he guesses the answer. 1 by 4 is nothing but the probability of E2 because E2 is the event where he guesses the answer. What type of answer he can give? Correct answer only in this case. Then what are the chances? Probability giving a correct answer when he knows. Probability giving correct answer when he guesses. When I say probability of giving a correct answer when he knows the answer, there are 4 questions, out of which the 4 answers, he knows which is the correct one. And that is the event of knowing the answer, it is nothing but 1. So he knows that there are 4 choices. In that 4, which is the correct one, out of 4, which is the correct one, he knows it. Giving the correct answer in this 4 for the 4 questions, what is it? For the 4 options, what is it? So giving a correct answer when he knows the answer. So that is out of the 4 choices, giving the 4 which out of this 4 which is the correct one. The chances is only 1. He give 1 correct answer only for all of the 4 choices. When he knows the correct answer out of that 4, he can pick up 1. That is nothing but 1. But then given that, assuming that the student who guesses is even 2, that the answer will be correct with probability 1 by 4. So giving a correct answer when he is guessing the answer is 1 by 4 because that is already given in the data. Now, what is asked to find? What is the probability that the student knows the answer given that the answer is correctly? Knows the answer is event 1 and it is given correctly means you are finding knowing the answer what are the chances of giving the correct answer. That is, you will find using Bayes' theorem probability of event A when event E1 when event A is occurred. Probability of E1 into probability of A on E1. How many are there events? 2. So sum of 2 terms. Probability of E1 into probability of A on E1 plus probability of E2 probability of A on E2. Probability of E1 3 by 4 into A on E1 1. 3 by 4 into 1 plus probability of E2 1 by 4 into again 1 by 4. So 3 by 4 into 1, that is 3 by 4. 1 by 4 I can put outside. 3 plus 1 by 1 by 4 I have taken out. 3 into 1, that is 3 remains. 1 by 4 I have taken out. 1 by 4 remains. So I am here. If I simplify this, 3 by 4 divided by 1 by 4 into 4 is the LCM. 3 4s are 12 plus 1. 4 and 4 I can cancel. 3 by 13 by 2. 4 goes to the numerator. 4 3s are 12 by 13. So which one? Probability of the student who knows the answer event 1 when giving a correct answer is 12 by 2. That is the value what you get. Next question. A man is known to speak truth 3 out of 4 times. He throws a die and reports that it is 6. Find the probability that it is actually 6. So here, the first statement says that a man is speaking the truth. Given out of 4 times, 3 times he is going to speak the truth. He throws a die, that is the event, random experiment what has occurred. He throws a die and it is found to be 6. On a die we know that it is from 1 to 6 numbers. So that is the random experiment. And the chances here it is saying that it is reported that it is 6. Find the probability that it is actually 6 when he is speaking the truth. Truth is that event. So here, die is an experiment, random experiment what is there. So event 1 and event 2 when I take, it is 6 on die, not 6 on die. These are the only 2 chances. So the 2 events what can it be? Either I can get 6 because that is the only one. It reports it is 6. 6 on a die occurring, that is the first event. Or from 1 to 5 any of the numbers occurring, that is event 2. Not 6 from 1 to 5 any of the numbers. And A is an event of speaking the truth. Because given that person speaks truth when 3 out of 4 times. So out of 4 times, 3 times he is going to speak the truth. So that is the truth A event what is going to occur. Now let us see how to rearrange this. Now first one, probability of E1. This random experiment we know what it is. It is nothing but a die throw. So probability of appearing on a die. Probability of 6 appearing on a die. What are the chances? 1 by 6. In this sample space, when I take a die, there are from 1 to 6. The sample space is nothing but the possibilities are 6. The total outcome is 6. The event occurred is only one favorable outcome, that is nothing but on a die 6 is appearing. So probability is number of favorable outcome divided by total number of outcome. Favorable outcome is probability of getting 6 on a die. 6 on a die is 1, only one chance. Out of total outcome is 6. Probability of E2, what is that? Probability of not getting 6. Not getting 6 on a die. What are the chances? The number of favorable outcomes of not getting a 6 is 6 is only one chance. Not getting is 5 chances. So 5 by 6. So this is the probability of E1 and E2. But here, speaking the truth is what is asked. Probability of speaking the truth when 6 is appearing. Probability of speaking the truth when 6 is appearing on a die. What are the chances they give? The man is known to speak 3 out of 4 times. 3 by 4. Probability of speaking the truth when he is getting other 5 numbers, that is 1 to 5. I can say it is nothing but 1 minus 3 by 4 complement. Whenever we got A dash if I want, is it not 1 minus A I can consider? A is the given what I have. A dash is nothing but 1 minus A. So this if I take 4 is the LCM 4 minus 3 that is 1 by. So probability of speaking the truth when the other 5 have occurred, either 1, 2, 3, 4, 5, 6 is occurred. Giving 6, the other 3 is occurred. 1, 2, 3, 4, 5. Out of this, anything occurs on the time. And what are the chances of him speaking the truth? It is 1 by 4. 1 minus A, 1 minus 3 by 4, that is 1 by 4. What is asked to find? Probability that it is 6. Which is the chances of 6 getting on a time? That is E1 or speak to the truth. Probability of E1 and speak to the truth. So that is what I have to find using base E1. So using the data, let us simplify. Probability of E1, that is getting 6, and speaking the truth, it is probability E1 into probability of A on E1 divided by probability of E1 into probability of A on E1 plus how many events are under? 2 events. Probability of E2 into probability of A on E2. Probability of E1 1 by 6. Probability of A on E1 3 by divided 1 by 6 into 3 by plus probability of E2 is 5 by 6 into A on E2 is nothing but 1 by. Let us simplify this. 3 by 6 into 4. Can I take out 24? 6 4s are 24, that is 1 by 6. 1 by 6 into 4 is common. What is left out? 3 1s are 3 plus 5 1s are 5. 3 divided by 10. 5 plus 3, that is 8. 6 and 4 were common multiples. I kept as it is in the numerator. Denominator I have taken out common because it is sum of the terms. Cancel. 3 plus 5, that is nothing but 8. 3 by 8 is the answer. The next problem. Suppose we have 4 boxes A, B, C, D containing colored marbles as given below. So we have a data where there are 4 different boxes A, B, C and D. They named 4 boxes and what are the marbles containing in them. And this is the data what is being given. Boxes are 4 A to B. Marble colors are 3 types, red, white and black. And how many are there in each box? In box A, totally there are 10. 1 red, 6 white and 3 black. 10 balls are, so 10 marbles are there, where 1 is red, 6 are white and 3 is black. Similarly, what is the data in box B? What is the data in box C? And what is the data in box D? One of the boxes has been selected at random. They pick one of the boxes out of the 4. And a single marble is drawn from it. From the 4 boxes, 1 box is picked and the marble is chosen. If the marble is red, that is given here. What is the probability that it is drawn from box A? So you have to find the probability of drawing from box A the red marble. So let us rearrange it on the data. Now, this is the box what is given. So can I say there are 4 events what are occurring? What are the 4 events? Box 1, box 2, box 3, box 4. Here they name the box as A, B, C. So here the right way, I can say probability of E1, probability of box A. Or I'll name the boxes first. Box A, I take it as box A, event E1. Box B, event E2. Box C, event E2. Box D, that is event E2. So these are the 4 events, 4 different boxes. And what is event A? Choosing the red marble. Choosing the red marble is nothing but event A. Now from the data, let me write down. What is asked to find? Find the problem that is drawn from box A. Box A is what? Red 1. What are the chances of getting a red ball as to be found? Now, Probability of E1, probability of E2, probability of E3, probability of E4. So four different boxes, four different events are there. So the chances are 1 by 4. The chances are 1 by 4. Each event can occur out of the four chances. Either picking the first box, maybe totally there are four boxes, the chances of getting box A is 1 by 4. So 1 by 4. And probability of getting a red marble from box 1. Probability of getting a red marble from box 2. Probability of getting a red marble. Probability of getting a red marble from box 4. Let us see how to rearrange. Probability of getting a red marble from box 1, I have to use this table and rearrange. Now, in this table, we are saying in box 1, there are totally 10 marbles. 1 plus 6, 7, 7 plus 3, 10 marbles. The chances of choosing red marble is only 1. The remaining are 6 white and 3 black. So I cannot choose that. I choose only the red marble. Red marble from box 1 is 1 by the total number. What is the total number? When I go to red marble from box 2, red marble in box 2 are 6. White is 2 and black is 2. Totally 10 are there in box 2. But the chances of getting a red marble is 6. So 6 white there. Red marble from box 3. Red marble already are 8. 8 by total is again 10 only. 8 plus 1, 9, 9 plus 1, 10. In box D, it says there are no red marbles at all. 6 plus 4 is 10 marbles are there, but they are white and black, they are not red. So I have 0 by 10, which is nothing but 6. So this is the data using the box what I have obtained. That is, this is the data box what was given from that PFP. Now let me find probability of it was drawn from box A. From the first box, what are the chances of getting a red one? So probability of finding from box 1, box A red one. So it is probability of E1 into probability of A divided by summation. How many boxes are there? Sum of 4 terms. Probability of E1 into probability of A plus probability of E2, probability of A on E plus probability of E3 into probability of A on E3 plus, I write down below, probability of E4 into probability of A on E3. Let me substitute the value. Probability of E1, 1 by 4 into probability of A, 1 by 4 divided by first one. 1 by 4 into 1 by 4 plus 1 by 4 into getting a red ball from box 2, that is 6 by 10. 1 by 4 into getting a red ball from box 3, 8 by 10 plus 1 by 4 probability of E4 getting a red ball into C. So if I simplify this, one by 40 potenza in the denominator also I will got 40 common. The last one is 0. Even anything is nothing but 0. That I leave it as it is. Again, potenza 40, potenza 40, potenza 40, that I take. 1 into 1, 1 plus 6 ones are plus 8. 40 and 40 I can cancel. 1 by 50. 1 by 50 probability of getting from box 1, that is box A, a red marble. Probability of getting from box A, the red marble is 1 by 50. So this is how using the table you can figure it. You can find probability of box 2 getting a red mark. The same data, everything use that, but from box B, how to get back a red mark? You can find out that similar way you can use the formula and try to. So these are the few problems on Bayes theorem what you have. So we have worked out the problem in the previous class and this class. As I told you when I started also, this is one of the important questions. You will get one 3-mark problem on this. So this topic of Bayes theorem, try to practice the problems. That's why after you complete for box A, try the same thing for box B and box C also. You can get back the value. So similarly, try to work out this and all the problems what were done in the previous class and this class practice this. Any doubts you can ask. So these are the ones on Bayes theorem. So this ends the chapter probability. In your textbook, there are continued after this. You have after this random variable, problems on that. Then you have probability distribution. Then you have binomial distribution. But all this is deleted from the syllabus for this year. For this year, there have been the deleted portions. So for that, it is not there. Only the retained portion is starting from conditional probability, then independent events, then we did multiplication theorem and Bayes theorem. So these are the 4 what you have. You have learned that and worked out the problems on this. Try to practice. These are the ones which are retained portions. Conditional probability, multiplication theorem, independent events, and Bayes theorem. What were worked out in these classes of probabilities. But in your textbook, after this, it continues with random variable and binomial distribution, all this, but that is deleted for this year only. So this year, that portion is gone. The remaining, what is there up to today's class, we have completed the whole syllabus, what is retained for this year in probability. Thank you, students.